Object-oriented programming, or OOP. You might have heard these two terms, but do you know what these concepts consist of, or how by applying OOP in your code you can easily maintain it for a long time? In this video, I will explain to you what is object-oriented programming in simple terms and what principle it contains. I remember the first fundamental concept of programming that I learned when I was studying to be a software engineer was object-oriented programming. It's a programming paradigm based on the concepts of objects. When a person learns to code, most of the times they start to write the code in a procedural model. This way they will start to put everything together, they will add different functions whenever they need it, and most of the time these functions are relying on each other. This way all the code is tangled together, and whenever you want to change one of the functions and make it something else or add something new to it, you need to make sure all the other functions that they are depending on these functions, they are also behaving the same and they know that this change has been made, so the output would be the same. This way of programming creates several issues down the line. Whenever you are programming in a procedural manner, everything is connected together, the structure is not really known, and there might be lots of different issues coming up whenever you are changing something. You are changing something at the top, something at the bottom will crack down and it doesn't work, and that's why they are calling it a spaghetti code, because everything is tangled together and everything is relying on each other, which is not good. For solving this issue, we have object-oriented programming as a paradigm model for how you can structure your code, and you can create objects, methods, and so on. Most of the high-level programming languages support object-oriented programming and the functionality it's built in. These languages would be Java, Python, C++, C#, PHP, and so on. In object-oriented programming, you have classes. These classes are representative of different data type or different object type. So in object-oriented programming, what you do is that you will create objects from these classes, and each of these classes, they have their own methods. Methods are the function specific to each class. As an example of what a class could be, I can say that a user in an application would be a class. You might have a user class which will represent a user. So whenever you are interacting with one of your users in your code base, you will create an object of this user class, and this object of the class, it has its own methods that you can interact with this object. These methods would be then edit of a class, add a class, remove a class, and so on. Classes in object-oriented programming, they have properties as well. These properties are variables or data sets that we are assigned to each object. As in our previous example of a user class, a user object might have properties like username, name, password, age, address. For example, your user class might have a method to change the address of the user, or it might have a method to change the age of the user or add a new age to the user. So the good thing about having a classes is that you can specify some rules in these methods that you're making sure that whenever somebody is adding a new age for a user or changing the age of the user, it's contained in some limit or range. For example, you cannot have a user with the age of -2. So for this reason, the methods of each class, they are responsible also to make sure that the data that you are putting for that class and you are setting the properties of that class are in the good order. So one of the other examples that I can mention for you is that imagine you are running a web application for an e-commerce website. So in this web shop, you might have different items or you have different products. These products, they can have their own class, which means that they might have properties as name, price, description, images, and other properties that you might think it would be relevant for a product. Then you might have different methods for this product. For example, you can have a method to specify if this product is on sale or not. As I said, when you have different methods for different classes, you can specify some rules in them to make sure that the data you are receiving is correct. If the properties that you had was something that everyone could access it, somebody by mistake, they could put some data, like for example a string of some characters instead of some numbers, for example for the price of your product. But if you have a method specific to setting the price of a product, you can specify that okay, this method is only accepting integer or float. So this way you are making sure that the data you're receiving, it matches the properties of the property that you have. Object-oriented programming in general, it consists of 4 different principles that I will gonna talk about now. These 4 concepts are data abstraction, encapsulation, inheritance, and polymorphism. So let's talk about data abstraction. In object-oriented programming, we have data abstraction. Whenever you are creating an object from a class, there are methods that you are accessing to and you are calling them, and they are performing some task for you. The beauty of this method is that you don't need to really worry about what each method is consist of and how they are working. So you have different methods that they do some specific tasks, and you don't need to worry about how they do this specific task. So you just call them and they work. This way you are always sure that this method, it performs a certain task, and you are not worried how these certain tasks would be performed. So in future, if a developer says that okay, this way that the function is working or this method is working is not really efficient, I want to change how it works, but he needs to make sure that the end result and the output of this method is the same as before. So in your code, the code is always checks the method and it does the job that it needs to do. So this way, you are always 100% sure that the data or the output that you are desiring is there, no matter the method. That's called data abstraction. So in data abstraction, you are not worrying about what is under the hood of each method. The next thing is encapsulation. So in encapsulation, your object, it has several different properties. So whenever you are calling different methods, there is a possibility that this method doesn't need to know these properties because it's part of the object and it has access to those. Imagine you want to show the age of the user in your application. If you're working in a procedural language model, you might have some function that it will get back the age of the user based on the year that they were born on. But if you're working in object-oriented programming, the year that the user was born on is part of the object properties. So this way you will just call a method called getAge, and it will get the property from its class itself, and it sends you back the age of the user. So this way you are trying to limit the number of variables or the values that you are passing on to different methods and functions. This way the error rate will be much lower than before. Now let's talk about inheritance. As the example of a user class that we talk about, now imagine your application is a part of a school application to get the data of all the teachers, students, and whoever working in that school. Now you might have a user class, it means that whoever is working on it, and then you have a class for teacher, class for students, and class for the workers. As you see, each one of these classes as a student, teachers, and worker, these have some common properties with each other like name, age, and so on. This way the class of the student and the teacher will inherit the user class, and they will get the common properties and the methods that the main class has. The next principle is polymorphism. So for explaining polymorphism, let me go back to my previous example. So let's think about a teacher as a class and workers of a school as another class of users. The thing is, because both of them are part of our main user class, they might have a method called getWorkingHours. So we are accessing the same method for both classes, which makes the job much easier for us as a developer. And because these two classes are separate, the output that they will produce are depending on each class and how the calculation is being done. For example, we might know that the teacher is working 5 hours per day during the working week. But for example, for somebody else who is a worker in the school, he might work other hours or different hours per day. And so this way, we're having only one function to get the working hours, but because they are different classes, they will send different number out. So at the end, when these four principles comes together, it makes your job much easier as a developer. With the inheritance, you can take care of the common methods or common properties between different classes, and with polymorphism you can distinguish between output of the different methods as well. And with data abstraction, you are not worrying about what is underneath each method and how they perform their job. And with encapsulation, you are making sure that you are passing less and less variable to your methods, and this way you have a safer environment to work on. So that was a wrap for object-oriented programming. If you like this video, please like, subscribe and press on the bell notification so you will be notified when I'm uploading similar videos to this.